Hi pre-calculus students, we're on the big finale of our 3 videos. Our first video was on special right triangles, and we're going to be using those values today on our unit circle. Our second video was radians, and we're also going to be filling in radians on our unit circle, and we're going to be bringing all the ideas together. So the reason why the unit circle is so important is the information that comes from it. We use a ton in AP Calculus. So if you are going to take AP Calculus, don't be scared. I have great ways for you to remember the information on this circle, but you will need to have it memorized. And that's not because I'm a tough teacher, it's because AP Calc requires that you do. So today we're going to look at the unit circle. So we're going to put the camera on this big unit circle for a minute so that you can pause it and you're gonna sketch it yourself. Or if you wanna print one that looks like mine from the internet, you're welcome to do that. We're also going to, if you want to, on the right in brown, this is gonna be some helpful information for you. So if you wanna write that down, also before I get started, that might make everything go a little smoother for you. You will be uploading these notes to me when I let you know, no worries today, showing that you took these notes.
Okay, disregard, if you can't see the top, that's for Miss Culver only. So don't worry that you can't see that. I just was reminding you.
Thank you, that's Bill. It's for those are my own little notes because there's so much. So this is gonna take a little bit that I wanted to be sure to do it in the right order. Also over here on the left, you don't need this circle. I'm just gonna be referring to it. So big unit circle and the brown writing on the right. So let's get started. So it's called the unit circle because the radius is 1 unit. And that's really not a surprise because when we did our radian measures, we said that no matter how big or small that radius is, it's 1 unit long. And so on our unit circle, the radius will be 1 unit. Okay, so I just want to, let's get our radians done first. So what we're gonna do is, notice I already put 0 degrees. I put the degrees all the way around in blue, and we're gonna fill in the radians in red from information that we know from video number 2. So, of course, when we start here at 0 degrees, that is also 0 radians. Now what I'm gonna, oh, there's Kidders.
Come say hi.
Kidders, did you come to learn the unit circle? Hi, Pumpkin.
You know I'm allergic to cats, Kitty. Okay.
That's a lot of cat. So what we're gonna do is, my method for filling in the radians on the unit circle is I start counting 30 degrees. We're gonna wait, we're gonna do the 45, but that will be next. So what we're gonna do is every 30 degrees, we're gonna fill in the radian measure, and we're gonna do that just by counting. If you remember from our radian video, 30 degrees is pi over 6 radians. So let's count. We might have to simplify some fractions a little bit. So 1 pi over 6, another 30, 2 pi over 6, that reduces to pi over 3, 3 pi over 6 reduces to pi over 2, 4 pi over 6 reduces to 2 pi over 3, 5 pi over 6 doesn't reduce, 6 pi over 6, that's pi. And take a look, we know we're right here. We said 180 degrees was pi radians. Let's keep going. 7 pi over 6, 8 pi over 6 is 4 pi over 3, 9 pi over 6 is 3 pi over 2, 10 pi over 6 is 5 pi over 3, 11 pi over 6, and 12 pi over 6 is 2 pi. just like we said when we did our radian video. Notice all we're missing are the 45s. Let's start counting. We said for radians that 45 degrees was pi over 4. Let's start counting pi over 4s. Here we go. 0. Here's 1 pi over 4. 2 pi over 4 is already filled in, but look, we're right. 3 pi over 4. 4 pi over 4 is already filled in, but we're right. 5 pi over 4. 6 pi over 4. 7 pi over 4. And 8 pi over 4. Now all of our radian measures are filled in. Isn't that really cool? The next thing I want to point out to you is we're going to start filling in the cosine, sines, and tangents. And take a look here, cosine, sine, and tangent. So how come it looks like cosine and sine, those values, I'm going to put into, doesn't this look like an xy point with the parentheses and the comma? That's because it is. Cosine is actually equal to x. Sine is equal to y. And so tangent is y over x. Now, how come I can say that? Let's take a look over here. Again, you do not have to draw this circle. I just have it here for reference. So take a look. Here is an xy plane that I put a circle on, right here. So if you notice, then we made this a unit circle. The radius for each of the colors is always 1. So take a look here. Let's look at this red 30-degree, 30, 60, 90 triangle in the first quadrant here. If I asked you what is cosine, you would tell me the adjacent side over the hypotenuse. You would tell me x over 1. Well, we don't need to divide by 1, so cosine is just x. Let's take a look. If I asked you for sine of 30 degrees, you would say, well, that's the opposite side over 1. And you go, oh, well, that's really y right there, and y over 1, and that's why sine is y. And if I asked you what is tangent, you would tell me opposite over adjacent, which is y over x. And that's why we're going to put cosine where the x is, sine where the y is, and tangent is y over x. So let's come on back. The first thing we're going to do is fill in what we call the quadrantal angles. They lie in the quadrants, the 0, 90, 180, and 270. Let's fill in the cosine, sine, and tangent there because they're easiest. Take a look here. 0 degrees. Let's fill in cosine, sine, and tangent. Well, take a look here. See that point right there? If this radius is 1, isn't that the point 10? That was easy. Cosine is 1, and sine is 0. I might have to get a darker marker. Let's see.
Yeah, it's a little light.
Let's do that in blue. Nope, that would look like degrees.
Try brown.
Let's try brown. There we go. There, that point is 1, 0. Class, if you put cosine of 0 degrees into your calculator, it's going to give you a 1. Okay? If you put sine of 0 degrees into your calculator, it's going to give you a 0. Now, how do I get tangent? Tangent is the lines on the outside. Hey, we said it's y divided by x. I've got a x and a y. Y divided by x is 0 divided by 1 is 0. Awesome. Okay, let's go up to 90 degrees. What is that point right there? 0, 1. There's cosine and sine. Let's get tangent. Y divided by x, 1 divided by 0. Oops, that's undefined. Class, if you put tangent of 90 degrees or tangent of pi over 2 into your calculator, it will say it's undefined. Let's go over to 180. This point right here is negative 1, 0. There's cosine and sine. Y divided by x, tangent is 0. Let's come on way down here. This point right here is 0, negative 1. Cosine, sine. Sine divided by cosine or y divided by x is also undefined. Tangent of 270 degrees is undefined. All right. Let's fill in the other blanks. Let's start with 30 degrees or pi over 6. So take a look here. This triangle right here that has an angle of 30 degrees, I did that in red over here. Here it is so that you could see it. Well, class, we need cosine of 30 degrees, sine of 30 degrees, and tangent of 30 degrees. We already know what that is, right? We already did that, right? On our special triangles video. This cosine is the square root of 3 over 2. Sine of 30 degrees is 1/2. And we already said that tangent of 30 degrees was the square root of 3 over 3. We already did that. Let's go back to this little circle here. Do you see in the second quadrant, right here at 150, isn't that also the same triangle, but in a different quadrant, 30, 60, 90? And in the third quadrant, isn't that the same triangle at 210? And in the fourth? So the cosine, sine, and tangent must be the same. They're all the same triangle. So let's go ahead and fill it in. There we go, square root of 3 over 2 and 1/2. Square root of 3 over 3. Here we go. Square root of 3 over 2, 1/2, square root of 3 over 3. Hopefully I won't make any silly mistakes. These are a lot of details. Right here, square root of 3 over 2, 1/2, square root of 3 over 3.
Can I just ask a question?
Yeah.
Because I'm trying to learn too.
Yeah.
How come, because you're in negative territory there, how come none of those are negative?
Oh, very good. That's next, Mr. Bauer.
Oh, okay.
Very good. Very good. Right now, I just wanted to see the pattern with the values, and then we're going to show positives and negatives.
Oh, okay.
Very good. Let's go to the 45. We already did cosine of 45, sine of 45, and tangent of 45 on our other video. That is the square root of 2 over 2 for cosine. Square root of 2 over 2 is sine of 45, and tangent of 45 was 1. Again, let's look at the green triangles. There's a green triangle in every quadrant, and so it must have the same cosine, sine, and tangent values. Let's fill those in. What I love about the unit circle is that it makes so much sense.
To you.
To them too, Mr. Bauer, and it sounds like you're starting to understand it also. There we go. All right, so our last spots we need to fill in are 60 degrees, cosine, sine, and tangent of 60 degrees. Again, we already had that from our last video, so let's fill that in. Cosine of 60 degrees is 1/2. Sine of 60 degrees is the square root of 3 over 2, and we found tangent was the square root of 3. Coming over to our small circle, that would be the purple triangles, and they are all the same. They have the same value, the same shape, and so they must have the same cosine, sine, and tangent. Let's fill those in. 1/2 square root of 3 over 2 and the square root of 3. 1/2 square root of 3 over 2, square root of 3, and last, this is going to feel good to have this done. 1/2 square root of 3 over 2 and the square root of 3. Awesome. Okay, we're almost done with the unit circle. Class, as Bill stated, and that's pretty cool. I didn't even tell him to say that, that he noticed that. And let's talk about then, what about the positives and the negatives? And what do I mean by that? Well, we have a problem here. If these are actually points right here, and they are, then over here, this is the second quadrant. Aren't the x's negative and the y's are positive? Right? And in the third quadrant, well, the x's are negative and so are the y's. And of course, in the fourth quadrant, the x's are positive and the y's are negative. So now all we have to do, we are going to fix that, right? So in the first quadrant, everything is positive, the x's and the y's. Let's go to the second quadrant. Notice the x's are negative. Let's fix that. The x's are negative. Notice that the y's are positive. Okay, but we said tangent is y divided by x. And what's a positive divided by a negative, Bill?
Well, to make a negative, you need a positive and a negative multiplied together.
Good,
So-
or divide, good.
Or
So
divide.
that means tangent must be negative. Sorry, I threw him in there because he was jumping in anyway. He did a great job. So because tangent is y divided by x, and that's a positive divided by a negative, the tangents must be negative also. Let's come on down to the third quadrant. Do you see the x's and the y's are negative? All right, so let's do that. And then tangent is y divided by x, and a negative divided by a negative is a positive. So we're gonna keep our tangents positive. Over in the fourth quadrant, x's are positive, y's are negative. Let's fix that. And tangent then would be negative also, because negative divided by a positive is negative. So now our unit circle is complete. Excellent. So, class, when I say you have to have it memorized for AP Calc, does that mean I throw a unit circle at you? No, it means I throw information at you. I go 60 degrees in radians, and you say pi over 3, right? I say, what is cosine of 30 degrees? And you tell me the square root of 3 over 2. You need to know each piece of information. Don't be scared. I have ways to help you with that. Let's come on over here. How do we remember at what degree measure or what radian measures are cosine, sine, and tangent positive or negative? How do we remember that? Well, we have a nice little trick because it helps. What we do is we make a big plus sign. Notice that also looks like the quadrants. And we put ASTC, all students take calculus. Yay, all students take calculus. But this tells us what trig functions are positive. In the first quadrant, all of them are positive. In the second quadrant, only sine is positive. In the third quadrant, only tangent is positive. And in the fourth quadrant, only cosine is positive. Isn't that cool? It's a great way to remember it. Now, what about the values in the first quadrant? And so if you notice, for cosine, sine, and tangent, we really only need the values in the first quadrant to know all the other values because they repeat. We just need to know if they're positive or negative, right? So how do we remember the values of cosine and sine and tangent in the first quadrant? So here's what we do. We take our left hand. Our left hand, oh my gosh, it's the first quadrant. When you look at your left hand, 0, pi over 6 or 30 degrees, pi over 4 or 45 degrees, pi over 3, right, and pi over 2 or 90 degrees. Now don't be concerned if you don't get this trick the first time. We do this a lot and you'll get it eventually. But here's what I do. Okay, when I know what angle I have, I'm gonna put that finger in, and cosine is gonna be the square root of the top fingers divided by 2, and sine is gonna be the square root of the bottom fingers divided by 2, and then we'll talk about tangent. So here we go. So can you put it on my hand there? Mm-hmm. Let's take a look. Let's say we want cosine of pi over 6. Here's the pi over 6 finger. Notice that there's 3 fingers on top. We're counting the thumb as a finger. Cosine is the square root of 3 over 2. It's always over 2. Let's take a look. Were we right? Yes, we were. Take a look. Let's go back. Sine of pi over 6 is the square root of the bottom fingers divided by 2. The square root of 1 is 1. Divided by 2 is 1/2. Take a look at this. Sine of pi over 6 is 1/2. Isn't that cool? Let's do our pi over 4 of 45. Cosine is the square root of 2 over 2. There it is. Notice sine is the same. Square root of 2 over 2. Let's go to pi over 3. We put that finger in. Cosine, Square root of the top fingers divided by 2. The square root of 1 is 1 over 2, 1/2. Sine is the bottom fingers. The square root of 3 divided by 2. Isn't that really cool? Now, technically, we don't need to know what tangent is, because we know tangent is y divided by x, or sine divided by cosine. So we could always figure it out. But there is a cool little trick. I'll show you. You don't have to remember this. Tangent is on the back of the hand. It's a little different. Let's just do 2 of them. Let's say we want tangent of pi over 4, 45. Let's put that finger in. Let's flip our hand over. Tangent is the square root of the top fingers divided by the square root of the bottom fingers. Square root of 2 over square root of 2 is 1. Here we go. Let's try pi over 3. Let's put it in. Let's flip it over. Here's tangent. The square root of the top fingers divided by the square root of the bottom fingers. That would be the square root of 3 over 1. And there we go. Isn't that cool? So students, this is a unit circle. You can probably tell I love it. If I could hug it, I would. And I hope you have a wonderful day. Thank you.
Never show the 45-degree radian by itself. That's a no-no on your hand.
Oh, yes, it is a no-no.
So
Very
kids,
good.
don't try that.
Don't do that.
Okay.
Thank you, Mr. Bauer.